After a few months of sun-up to sundown cutting, welding, grinding, allergic reaction to surgery, and full exhaustion, I knew the boat was not going to be finished before engineering school started. The next 2 days were spent resting instead of pushing to meet an unnecessary deadline. Classes were to begin in 3 weeks. The way to spend that time, best I could figure, was helping my friend Greg with projects he was working on, as a thank you for letting me use his property, tools, and equipment to build this boat. One of those projects was changing 4 rotten dually tires on a step van he had bought and needed to get back to the farm. We also spent some time helping our friend Sean pour concrete for the shop he was building. Around this time, Doug received an email from Chris Van at afterhourswelding.com, who offered to sandblast my boat at cost. When our timelines didn't match up, he then offered to give me a spare sandblaster for free. So Greg and I loaded up and hit the road to St. Augustine, Florida to pick it up. Once on the road, it didn't take long until we hit traffic. Once we arrived, we got a good look at Chris's sandblasting setup. He also gave us a 3-hour lesson on how to sandblast, sharing many of his trade secrets learned the hard way.
Out of an air cannon, it will pick you up and move you. When that grain of sand hits and it starts splattering out, it'll take off a piece of paint even bigger than it was. If it falls down to one piece, no dust. Take that beer bottle, throw it fast enough that when it hits the wall, it shatters. Now you've got 20, 50 pieces, and in the case of sand, that's dust flying in the air.
And then he gave us some stick time on his machine.
Now, what you found was the rate of travel that was optimal. If you go too slow, it's too clean, you're wasting sand, you're wasting time. If you move too fast, it didn't clean enough. Then you got to come back and hit it again. There was that optimal speed of travel, and I noticed within 1 second, you found it, you adjusted your speed, and you maintained. You're bright, you got an instinct for this. I did. A lot of people don't.
After having years of knowledge bestowed upon us, we loaded up our new blaster.
Don't want to smile? Yeah, that's very generous of you, absolutely. It's going to go to great use. For all the viewers, I loaded them on the cart. I didn't know there were 4. Later.
We ended up staying at Chris's a lot longer than we planned. The next day we did some sightseeing before heading back. We brought the trailer on this trip so we could pick up one of Greg's tractors and take it back to the farm. A crane came in handy while reinstalling one of the tires. Greg had doubts the tractor would start after sitting for so long, but one of the beauties of a mechanically injected diesel engine is they just work. Since we were already here, we reckoned on bringing the boat back as well. We just had to figure out how to trailer it. Stacking it on top of the tractor should work. We have the welder and some angle iron to build a rack over the truck if it doesn't. With everything strapped down, we hit the road back to the farm. On the way back, we stopped by a river for a swim to cool off. At the farm, we unloaded the boat, and this happened. That was my fault for not using my lifting straps, which are still on the barge from when we laid it down, and using a spreader bar with sharp edges. To make it even better, Greg did suggest putting protection on the sharp edges against the strap.
Do you want me to put some protection on these corners? No.
Fortunately, the only damage was a busted leaf spring on the trailer. The boat was fine. With only a few days till class, Greg moved one of his campers over for me to stay in while I commuted every day. I'm very grateful to be able to stretch my legs again at night, much better than the back seat of my truck. First semester of school went very well. One of the projects I worked on was a 3D printed boat drag race competition in teams of 4. The challenge was to design and 3D print boats that would compete in a 30-foot drag race at the end of the semester, with the fastest team getting the highest grade, and all other teams being judged off the fastest time for their grade. Each boat had to use the same motor for propulsion and only use batteries available near the checkout aisle of a big box store, amongst other rules. You're looking at some CAD models we designed, with this one being our final iteration. The final design ran off 2 parallel sets of 3AA's in series for the drive motor fired off of a relay, and 2 CR2 batteries in series to power the rudder, receiver, motor controller, and trigger the relay. We printed several boats during the design and testing phase, only a few are pictured here, and the gray one is the one we competed with. This project was my first experience with 3D printing. I enjoyed it so much that I bought my own, in part because I didn't want to wait for one to become available on campus, and because of how powerful a design tool it is. Concept to part in your hand is lightning fast, particularly with these new Core XY printers that run on Clipper and use input shaping. We did a ton of testing on this boat project. We even designed and printed this thrust tester so we could accurately compare the changes in variables like shaft diameter, density, and length, as well as propeller material, pitch, diameter, and number of blades. In the end, it was our battery testing that really gave us the edge. Like most teams, we banked on the idea of using higher voltages for the race. 9 volts provided the most thrust, but we found 9-volt batteries did not provide enough current when compared against their weight. We had to write several reports, and when we gave our presentation 2 weeks before the race, the professor changed the scoring metric to, quote, boost scores in case one team is significantly faster. On race day, we did very well. The runner-up was more than double our time, and the average time was quadruple ours.
Good, that's fine. That's good. Anyway, that's good. Whoa.
Dr. Reynolds, you're gonna have to get this one.
I got it. 8.4.
At some point along the way, I built a new computer. My old laptop could no longer handle the video editing and CAD work. A fast processor was essential, but the biggest improvement was the upgrade to M.2 RAM for significantly faster file speeds. Running a liquid cooler on the CPU and multiple fans was also critical since I don't have air conditioning down here in Florida. The build, while I don't have a metric about how much time it has improved my workflow, it definitely is more of a pleasure to code, CAD, and edit video on, a worthwhile tool to invest in. With the fall semester over, I traveled quite a bit, visiting with family and friends, even giving a few speeches at a career academy. In my travels, this lathe was given to me by a widow, a tool I'm very thankful to own. A couple of weeks ago, I was very fortunate to sail Seeker from Tampa to Pensacola. It was wild to witness a boat that weighs approximately 65 tons to maintain just over half the wind speed for hours at a time. The boat's speed is top right, and the wind speed is 2 below that. Along the way, I had to make a repair to one of the 2 drive shafts I made. We decided to pull into Port St. Joe simply to see somewhere new, and just after dropping the sails and switching to engine, I pushed the pitch of the blade too hard and then increased the throttle. The built-in shear point between the yoke and splines sheared.
Do it again, but a little more motion.
This is the shaft here. The right side connects to the transfer case and the left side connects to the Allison transmission. We needed the shaft a telescope like this for easier installation and to make locating the case easier. Here are the 2 welds that connect the splines to the yoke, only on 2 edges to create a weak point that would break and be easy to repair, hopefully before something more expensive breaks under heavy shock loads. I machined this hole using the Tormach that the splines slide into to locate it accurately. To weld this back together, the challenge is to make sure both yokes are clocked in the same plane. To beat that challenge, we came up with this jig. Clay provided downforce while I tack welded the splines in place.
Yeah.
Then we could TIG weld it out. The joints are also cleaned with a die grinder beforehand. And just like that, the drive shaft is back in. Nothing to it. Shortly after, the sails went back up and we were again underway. With one semester down and the holidays at an end, the only thing left to do is to get back to work. First thing up is to finish welding this right side. I gave it a deep V-groove with the grinder first to get a deeper penetrating weld. I did have a large gap in one area that took several passes to fill. With the side 100% welded, next I needed to fill in the holes in the C-channel. To do that, I removed rust from the inside of the hole with a die grinder and then took paint off the face with a flap disc. I'm using this copper bar as a backer so the weld won't fall out on the other side. It's on loan from Doug, who said it's not that it's worth a lot of money, but he got it from a good friend who is no longer with us. The copper block does a good job at helping fill the holes. I also started capping some of the ends of the pipe with plate. This time around, I'm adding an exhaust to the generator. I made a flange that'll connect to the manifold, then added a transition piece, flexible coupler, and muffler. Something will need to support the muffler, so I'll use this table. A piece of railroad track will be a good thermal barrier between the muffler and table. This floor stiffener is bowed, so I'm going to bring up the bottom to meet it. Luckily, this power line pole is right underneath of it for me to push off of. Bottle jack closed the gap up nicely for a couple of tack welds. Now I just need to scoot the pole in a little further so I can close up the rest of the gap. It's a little heavy. This side is all done. Time to do the other. I'll start by roughing in the level, then I'll go back and fine-tune each pipe one at a time when the C-channel is cut off. Raising was a slow process, adding one board each couple of inches. The C-channel that was used as the base comes off next. Before I can start leveling each pipe, the laser drew a level line on the completed side C-channel. Then I measure from the line to the top of the C-channel and adjust front and rear of the boat until that side is level. I quickly realized I needed smaller shims to fine-tune the pipes, so I cut up some 3/16 flat bar. I'm using a laser level and story pole to level each pipe. You can see on this story pole that the laser is above the witness mark, so the pipe needs to go up to meet it. Perfect. It's almost time to put the left side C-channel in place. This brace needs to go, and in its place I can use a ratchet strap to hold the rake in position. These bow plates need to be straight where the side attaches. I'm using this board to straighten them, then I'll weld in a temporary brace. With the laser set higher, I recorded where it landed on the bow side plate. Then I transferred it to the new side plate over at the steel rack. This short section of C-channel provides enough pressure to keep the plate flat. And this piece of scrap locates the plate left to right. Then all I have to do is raise the plate until the laser hits both marks. A jack will make sure this side doesn't sag when the C-channel swings in. Always good to have a truck that you can set steel plate on your fender from the crane. Both sides in place and the laser reset, I can record measurements of where to place this side's C-channel and then transfer them to this side's plates. And weld on some brackets for the C-channel to sit on, which has a bend in it that I'll take out with this rosebud. Careful measurements paid off with a nice gap for the weld, and the torch straightened the C-channel right out.